Now to finish up with 203, what we're going to look at specifically is how the Earth's tilted axis affects where the sun is in the sky, the sun angle, how that affects the intensity or the strength of the sun, and how that intensity ultimately causes Michigan to have its 4 seasons. We're going to start with summer. So when we look at summer, what I want you to do is to first look at where the position of the Earth is relative to the sun. We are right here. And notice the northern hemisphere is getting more sun. But how does that affect the sun angle? If we are tilted towards the sun, that means the sun is higher in the sky. So if you look at this little box inset, you can see that the sun is at a very high angle, almost striking straight down on the surface. If you look at the lower left box, you'll see that the sun is very high in the sky. And as we run this through a day, you should see, if I can get this to work. Here we go. Let's try this. There we go. As you can see, that the sun itself will take a very high path through the sky. But as the year goes on, as summer becomes fall and fall becomes winter, things are going to change. You're going to start watching that sun angle start to drop. Notice the lower left-hand box. That arc, those dots are starting to get lower and lower and lower. And if we eventually speed this up, we're going to end up getting towards a lower angle. All right, so that's the first thing. So going back to our notes, what we're going to jot down is we know that we have a 23.5 degree tilt. And what we also said was that tilted towards equals a high angle. And that symbol that you see is actually the sun angle. Now let's look at how that changes in the wintertime. If we go to wintertime and we let this run really slowly, you're going to see that something different has happened. All right, looking at the wintertime, when we're looking for the sun in the sky, let's see what happens here. Low sun angle. Notice how low that sun is in the sky. Instead of being at that nice high summer sun angle, now it's in the winter sun angle. If we were to pause this for 1 second, take this back, you can see that the sun is actually at a very, very, very low angle. All right. Second part, sun angle and intensity. Obviously, if the sun is at a higher sun angle, the sun is going to be more intense. So a high angle equals more intensity. Higher sun angle equals more intensity. And ultimately, if we have more intensity, we're going to get summer. So more intense sun equals summer. Very simply put. Whoops. And that's summer. Sorry for the spelling error there. That's summer. And of course, less intense sun equals winter. Let's take a look at another way to view this. And this is a program we're going to use a lot during the astronomy unit. But if we set this in motion, you'll see right now we're set to what season? Northern hemisphere tilted towards the sun. This has to be summer. Remember, this diagram looks a little different from the other one. It's opposite from your diagram in the notes, but it's okay. When we get this thing going in motion, we slow it down a little bit. You can see that as the Earth revolves, looking at this graph in the bottom right-hand corner, we get a nice fluctuation or change in temperature from our wintertime temperatures to our summertime temperatures. And it all has to do with the tilt. All has to do with the tilt. If you were to go to another place on the Earth, that you would have a different result. For example, if we were to switch latitudes, let's compare Michigan, and we're going to go to the equator. If we were to put both of these in motion, you'll notice that the top line, the one that's almost going straight across, that's your equator. There's very little variation because they're always receiving a high amount of solar radiation. Why? Because the equator is generally getting more direct sunlight. Whereas our latitude, is getting a change in the amount of sunlight throughout the year. Last comparison, let's take our equator and move it up to the poles. And now you'll see a little different. This is going to be Michigan, and this is going to be the poles. Notice the change in temperature. We have our fluctuation, but they have a greater change or greater fluctuation. So wrapping this up in your notes, we have a tilted Earth's axis, which causes one hemisphere to get tilted towards or away from it during the year. How it's tilted towards or away gives us more or less intense sunlight. And if you get more intense sunlight during a time period, that's called summer. Less intense, that's called winter. And spring and fall are neither more intense or less intense. That's where the Earth is, our latitude is getting essentially the same amount of energy.